So welcome to this lesson, and in this lesson we'll be treating metallic bonds. So metallic bonds, we'll be treating metallic bonds, and let's see what we have. So first we'll start by an introduction of metallic bonds. So metallic bonds are a type of chemical bonding that arises from electrostatic attractive force. So they arise from electrostatic attractive force between conduction electrons and positively charged metal ions. So they are a kind of bonding that arises from the electrostatic attractive force between conduction electrons and the electrostatic the metal ions. So this type of bond is found in metals, and it explains why their physical properties such as chemical their conductivity, their malleability and their ductility tend to apply the way it does. So as we can see, these kind of bonds, they happen when we have aggregate of metal atoms together. So they occur when metal atoms are aggregated together and they are held together by a strong force, this electrostatic force of attraction in solid metals. So once this electrostatic force of attraction holds these metal atoms together, there is then a kind of delocalization of electrons between these metals. So the electrons that are supposed to be on each of these single metals would begin to move from one of these metals to another. So I can say it happens somehow in this sense. We have kind of twin that has or set of multiplets like triplets, just like plenty people that look alike. Then we have small children that don't really know the differences between um, each of these parents. So we have parents that look alike, completely alike, and then we have each of these parents have children, and these children seem not to know their parents. So what will happen is these children would come to one of the parents and see the next parent. This is my mother. Go to the next one. The next one is looking like my mother. They will keep on moving around each of these atoms. So when we have aggregate of atoms, each of these atoms are of the same metal, so they have the same. They are looking alike. So these electrons tend to know each of their own atom. But when there is an aggregate of these atoms, sometimes they would be confused and they would move across um, all the atoms present in that particular structure. So this is what happens, and they will form like a continuous movement of different children or different electrons going across each of the metal, trying to find the one that is their real base metal. So they might not be will not be able to find it, and this kind of continuous delocalization is what we call the formation of a sea of electron across metallic bonds. So this is how this movement, continuous movement, is what leads to the bonding or what they call metallic bonds. So chemical bonding, metallic bond. In metallic bonds, atoms in metallic elements form a kind of sea of electron, which I just explained. And this sea of electron is as a result of the movement, the free movement of this electron along, across all the metal atoms. So this delocalization of electrons across each of these metals makes for these binding kind of tendencies between metals and their like metals. So unlike ionic bonds or covalent bonds, metallic bonds do not involve sharing or transfer of electron between two species. So they just exist as a result of two species that are standing together, and the electrons are being just like just moving around. None of them is giving anybody an electron or sharing any electron with anybody, but the electrons are just moving by themselves across the metal because the metals are the same and they are alike. Sorry. So let's see the strength of metallic bonds. So strength of metallic bonds are vary across the periodic table, and it depends on some key factors. So some of these key factors are the number of the localized electrons. So when the number of the localized electron is more, the strength will be stronger. So metals with more delocalized electrons tend to form stronger metallic bonds. So another characteristic that is responsible for the strength of metallic bond is the size of the metal ion. So when the metal ion is smaller, it means the nucleus or the nucleus of that metal ion and the nucleus of another metal ion would be closer to themselves, because when they are very small, they will be closer. So when we have two big stuffs, like maybe we have two fat people, like very fat people, two fat people, we're talking about larger size metal ion. We are using it to represent larger size metal ion. Two fat people are standing in front of themselves with big pot bellies. So if these two people are trying to let their heart, if they stand tummy to tummy, facing each other, tummy to tummy, the distance between their hearts would still be far. The heart of one person and the heart of the second person will still be far. So, but when you have two slim people standing close to themselves, there is no tummy difference. Their heart will be almost touching each other. So, this kind of attraction or this kind of closeness is what leads to stronger bond between smaller ions. So, when the size of ion is bigger, it makes it difficult for the ions to be close to each other. So that's why smaller metallic ions tend to give smaller, tend to give stronger metallic bond. The same thing applies to other metallic or other types of bond when you're talking about their ion size. So ion size always, so long as the ion size or the atom size is smaller, it will always lead to a stronger bond. So now, um, another reason why this smaller size is leads to stronger bond in metals is because it leads to a kind of closer packing, like closer packing. When you are trying to pack these metal ions together, it allows, because their sizes are small, they can pack more efficiently. Just like as though you have larger size balls, trying to put them into probably a single bucket, a big bucket. So when the balls are small, you can be able to pack in more of these balls, and when you shake it very well, they will form a stiffer collection of balls. But when they are larger size balls, even if you pack them very well, you feel them in the drum. If you shake it, they will still be moving because of their sizes are not, there's less efficient packing. So this is another reason why metallic bonds, smaller size metal ions, leads to stronger bond. So transition metals typically have stronger metallic bonds compared to main group metals because the transition metals have more electrons that can be delocalized across their metal lattice. So the same idea of more electron leading to stronger bonds. So these transition metals, they are known for strong or larger amount of electrons. So for that reason, they tend to be stronger or forming stronger metallic bonds, comparing them to normal um, s orbital or s group metallic bonds. So a combination of high number of delocalized electron, compact metal ion structure would always, a combination of these two would lead to a stronger metallic bond. So this is why transition metals generally have a higher melting point and also a higher boiling point than main group metals. So let's talk about electrical conductivity between metallic bonds. So metal conducts electricity due to mobility of the delocalized electrons. So as I said in one of the lessons, I said when you have charges moving, you tend to create electricity, because electricity is the movement of charge, is formed as a result of movement of charges. So when we then have these electrons on metals continuously moving, it is the reason why metals are just naturally conductors of electricity, good conductors of electricity. So when the potential difference is applied between these metals, it will cause a potential difference, meaning when you put a positive and a negative side, there will be a directional movement. So the negative will then have a direction, and when this direction is now there, it will lead to the flow of electron or the flow of charges, which is known as electricity, so or current. So additionally, metallic bonds, they account for high thermal conductivity. So the same reason, because of the presence of the movement of these, the movement of these electrons, so they can carry the heat from one side of the metal to another side very fast because they continuously move across this metal. So let's see malleability of this thing, metal and metallic bonds. So another property that is explained by metallic bonding is malleability of metals. So metals can be hammered or rolled into sheets because of the layer of atoms that can slide over one another. So the reason why metals can be easily hammered into sheets is because we have this close packing of the metal ions. So when they are closely packed, they will kind of form, if you arrange them properly, efficiently, they will form a kind of layering. You have a level of circular metal balls on one level, then you have another layer of another metal balls on the next level, another layer of another metal ball. So this arrangement, this layering is what makes it easy for you to be able to hammer metals into sheets, so which is the property of malleability, because they will be able to roll over themselves. When you keep on hammering them, they will just roll and try to spread out because of the arrangement. So this is the reason, because of the kind of bonding that occurs in metals that is responsible for the malleability of metals. So let's see chemical bonding in metallic bonds. So this sea of electron model and band theory are both used to explain metallic bond. So band theory is that theory that tries to talk about how energy levels, there's difference between conduction band and valence band of electrons. So the band theory in particular provides an insight into into why some materials conduct electricity better than others by describing energy levels and how electrons occupy these energy levels. So when we go into hybridization and quantum theory in chemistry, we'll be able to understand this band theory in details. So, but it is one of the theory that also tries to explain why some type of metals, tend to behave better in conduction than some other metals. So, moving on. In conclusion, the summary states that metallic bonds is a key concept in chemistry, and this helps to describe how metal atoms are being held together. So the unique arrangement of delocalized electron results in metals' characteristics properties such as electrical conductivity, ductility, malleability, and also their luster or their luster. So these it's very very crucial that when we talk about metal, we understand how metals bond, because when we understand how metals bond, it would help us in our understanding for how metals would also react and how they would have some of these their basic properties or how their properties come about. So with all this being said, I'll say we've come to the end of this lesson, and I'll see you in the next.